Differential thermal analysis instrumentation. A typical DTA apparatus consists of a furnace, a sample holder, a furnace temperature controller, an electronic or any other type of recording device, and a millivolt DC amplifier. A schematic diagram of a DTA apparatus is shown in the figure. The type of equipment which is chosen depends on the materials to be examined. The most commonly used and very useful apparatus is the DuPont Differential Thermal Analyzer, which is employed both for low and high temperature functions. Furnace. The furnace tubes are made of stainless steel and are insulated. The outer case of the furnace is made of aluminium tube using asbestos wool as the internal insulator. The dimensions of the furnace tube are such that the sample holder fits snugly. Sample holder. Both metallic, that is of nickel, platinum, or steel, and non metallic, such as glass, sintered alumina, or silica materials, are employed for the fabrication of sample holders. Metallic holders give rise to sharp exotherms and flat endotherms. Non metallic holders give sharp endotherms and flat exotherms. The thermocouples which are employed are made from 28 gauge platinum and 28 gauge 90% platinum 10% rhodium alloy wire. One set is inserted into the inert material such as aluminum oxide, which does not change through the temperature range to be studied, and the other set is inserted into the sample under investigation. While selecting the thermocouple as temperature sensor, one should keep in mind the temperature interval, thermoelectric coefficient, chemical compatibility with the sample, and reproducibility of the EMF versus temperature curve as a function of thermal cycling. Various steps of temperature programmers have been developed depending upon the type of work or the degree of sophistication of the instrument. The most simple and usually employed furnace temperature controller is a variable transformer, but other programmers consisting of motors attached to a shaft have also been used. Recorders. Recorder is the most sensitive part of the DTA instrument, which records the delta T signal, that is the difference in temperature signal, with as little distortion as possible. The recorder consists of a galvanometer in which the reflected beam of light falls on a twin cathode photocell, and the unbalanced beam is fed into two thyratron tubes which are resistant cooled to the reversible pen driver. The chart drive is built from aluminium sheet, and the chart gear drive mechanism is made of aluminium rod. The chart is driven by a motor. Heating rates are adjusted continuously from 0 degree centigrade to 30 degree centigrade per minute, and the samples are heated up to 500 degree centigrade, or wherever required even up to 1000 degrees centigrade. The sample tubes are fitted with sample when the amount ranges from 0.1 milligram to 10 milligrams. Two sample tubes are used. One sample tube is fitted with the sample and another sample tube is fitted with inert reference material such as alumina, quartz, etc. The sample tubes are inserted into a block and they are heated or cooled uniformly at a constant rate. The temperature difference between the sample and the reference material is continuously measured and recorded against the furnace or reference material temperature. On heating, any transition or thermally induced reaction in the sample is recorded as a peak. In an endothermic change, the sample temperature lags behind the reference temperature because of the heat required to carry out the transition and hence develops a voltage. On the other hand, an exothermic change causes the reference material to lag behind the sample temperature and causes a voltage of opposite sign. Endotherms are usually plotted downwards and exotherms are plotted upwards.